You know, some people call the Cessna 206 Stationair a flying Cadillac Escalade, but I've always thought the 206 was more of a working pilot's airplane. The 2018 Cessna 206 Stationair is more like a luxury pickup truck. It works on floats, works on Tundra tires, and you could also put a cargo pod on it. And the 2018 is perhaps the most luxurious and capable 206 we've seen yet.
Hi, my name is Steve Kent with Textron Aviation, and it's my pleasure today to talk to you about the 2018 Turbo 206 Turbo Stationair HD. You can literally put anything that you want in the back within reason. If you can close the doors on it, you can usually fly it. So the 206 has its roots starting out carrying a big load into a short strip and make money doing it. Those commercial roots allow us to have a really strong and durable airplane that's extremely versatile. This airplane can be put up on floats, on oversized wheels and tires, and in some applications even on skis. The cabin is 4 inches wider than a Skylane, which is also 6 inches wider than a Skyhawk. You can easily fit 6 people in it and some bags. You can take off and land in 1,500 feet pretty easily. The door height was predicated on the height of a 55-gallon drum, and the width of the door is the width of a standard pallet. So obviously it wouldn't be configured as nicely as we have here today. It would be a more Spartan interior, but nonetheless the aft door folds back, as you can see, so you can throw some planks down, roll some drums into the back and go fly. We even made it better now for 2018. We have the Turbo 206 HD. I call it for heavy duty. It gives us another 189 pounds of useful load. That useful load, we were never really limited before, but now you can put even more stuff, take more friends, go further, carry more stuff. So the HD allows us to carry, as I said, another 189 pounds, and it really only raised the stall speed a few knots. So it's really been a great trade-off as an STC. So the third row seat in the Turbo Stationair has the ability to fold down flat, which gives you access to the cargo area behind, and also a lot of people just throw their golf clubs on top. While the seat is down, we can also move the front 4 seats forward and back on tracks. The other thing with the aft seat, the third row, is with these quick release pins down here, we can remove the pins and take the whole seat out. That saves you about 40 pounds if you needed that weight. So the aft door, the aft cargo door as we call it, was designed so that the width would fit a standard pallet and the height will fit a 55-gallon drum. The way that we do this, make it easier to load, is this prop rod will pop up and allow the door to swing out of the way. So you can back your pickup truck here, throw down some planks, and roll your 55-gallon drum or pallet into the back. The aft door has 2 separate latches that make sure it's secure, and then the forward door folds over the top of it. In an emergency, we really don't worry about the aft door. You only have to open the forward door to get out. We also have a pin switch here. So when this door is open, if power was on and the flaps wanted to come down, you would bend the door or bang up the flap. So with this switch here, the flaps will only work if the forward door is closed and latched. So the Turbo 206 has a Lycoming TIO 540 turbocharged power plant. It has 310 horsepower continuous. That engine is rated with a 2,000 hour TBO. As a matter of fact, if you were in commercial operation and operated it more than 40 hours a month, it goes up to 2,200 hours automatically. Very, very durable, robust engine. Excellent cooling, which we'll show some features of later. Personally, I find a turbocharged airplane easier to fly than a normally aspirated because you're not always messing around with mixture due to altitude changes. This engine always thinks it's at sea level up until 17,000 feet. The service ceiling is 27,000 feet, so above 17,000 feet you do have to lean like you do a normally aspirated airplane. The sloped controller allows us to have the appropriate manifold pressure regardless of how aggressive the pilot pushes the throttle forward. It protects the engine from overboosting. And if for some reason that slope controller did fail, we do have a mechanical relief valve that is set to mechanically open 2 inches over max boost. So the relief valve would pop open, the engine would drop below boost, slope controller would catch up, everything's happy, no teardown inspection, nothing, no maintenance required. Part of what makes the Turbo 206 such an excellent short field airplane, being able to get in and out of short fields carrying a big load, is the fact that we have tremendously effective flaps. All the high wing Cessnas do, 172, 182, and of course the 206. Big difference is 172 and 182 flaps end here. Same with the 180 and 185. The 206, you can see, has another 2.5 feet of flap. So we have 5 feet more flap than a standard high wing Cessna. So since we took 2.5 feet out of the flap to compensate for the effectiveness of losing 2.5 feet on ailerons, we changed the design to the Freeze type aileron. Freeze type aileron is extremely efficient. Number one, it's deeper chord-wise, but it also is hinged about 1/5 of the way back, or 20% mean aerodynamic chord of the aileron. That allows the leading edge to kind of trip the airflow and create a low pressure area back here. But also there's a gap that comes through and air can come up over the top, also creating downforce, which will get that wing down. We also have this stall fence here, so as the wing stalls from the inboard to the outboard, the contaminated airflow cannot reach the aileron. So the ailerons remain extremely effective even in slow flight. Part of what makes the Turbo 206 such a great off-field airplane is the fact that we have this solid leaf spring gear. There's no drilling for brake lines to make it any weaker. You can see we run the brake line on the outside aft portion of the landing gear leaf spring. This gives you an incredibly durable landing gear. The nose gear also has more travel in it than does a 182 or 172, so it helps cushion that off-road, off-field or soft field landing experience. So the way we handle the heat from a turbocharged 310 horsepower engine is in a number of ways. The first and most obvious are the cowl flaps. These cowl flaps are tremendously effective in creating a low pressure area that allows lots of air to come through the engine. Matter of fact, they're so effective, if you leave them open in cruise, it costs you 5 knots. So you don't want to do that. Additionally, we have what we call the shark gills. This also lets heat out. The turbocharger is actually right back here. This also lets heat out of the engine bay, even when the cowl flaps are closed. So the last thing that we do to manage the heat is we've designed the air intake so it has this sort of gentle S shape. So when you're at high angles of attack, when you're climbing, I'm going to use my hand to simulate the airflow. The air is going to be coming in this way, right over the top of the engine, through the cylinders and down out the shark gills and cowl flaps. However, when you pull your power back and you're descending, now the air is coming in this way, and this hood trips the air and creates a high pressure area in here and prevents the amount of air that would normally flow through. Plus you have your cowl flaps closed. This design, in conjunction with the cowl flaps, makes the Turbo 206 probably the most thermodynamically stable engine we have. Here we have the Stationair elevator. The Skyhawk elevator is about this long. Skylane elevator is about this long. Stationair, of course, goes to the end, but it also has this additional piece down below that gives you even more surface area for extremely good elevator pitch control. When you're carrying a lot of weight in the back of the airplane, it's real important to have a big elevator to be able to get the nose up. In the same spirit, we have the rudder back here. The rudder's quite large, makes it pretty easy to handle the 310 horsepower and the amount of torque that you need. A little bit of a trivia fact for you Skylane owners: if a Skylane fits in your hangar, a Stationair will fit in your hangar because it's actually 4 inches shorter nose to tail than a Skylane.
Just departed Wilmantic Wyndham in eastern Connecticut, and 120 knots or so indicated in the climb, gave us about 1,000 feet a minute. And you were talking about the cooling in this airplane. Let's talk a little bit about what we're seeing for temperatures now.
Sure. Our cylinder head temperatures right now in the climb are 365 degrees. really nice and cool. We talked about the shape of the air intake since we are in the climb. Cowl flaps are still open, so everything's working pretty well. We're running really rich right now too because we're in the climb. But yeah, our exhaust gas temperature's around 1340 and our TIT is pretty cool right now. It's about 1400 degrees. We do lean using TIT in this airplane. I really enjoy the 206 because of its cross-section. You can see I'm 6'5", 280 pounds, and it's kind of an airplane that's sort of built for my size, but you can load a bunch of stuff in it, and it's not the fastest airplane, but once we're leveled off, the higher you go, the better it gets.
Now, if cabin size and loading matters, the HD T206H, with a base price of $680,000, might be in a class of its own. Its nearest competitor is Textron's own Bonanza G36. It has less useful load, retractable landing gear, and a price that's north of $850,000.
We'll climb to about 7,500 feet here on a VFR day for our demo flight, but the airplane does have built-in oxygen?
It does, 6-place built-in oxygen. It's a 77 cubic foot bottle, so it's got a lot of capacity. I usually cruise around, I cover mostly the East Coast, so I'm usually around 9 or 10,000 feet, 11,000 feet, so I don't need to use supplemental. But if I have a big tailwind or weather or obviously terrain, then we'll go up high. Service ceiling's 27,000 feet, but we can make full power up to 17,000 feet. And at 17,000 feet max power, the true airspeed on this airplane is about 178 knots.
Look at some performance checks. We are on a full power run here. We're level at 7,500 feet. We're showing a true airspeed of 166 knots. Burning a lot of fuel though at 34 gallons an hour. About typical?
Well, for max power, absolutely. If you want to go this fast, this low, this is what it takes to get. The nice thing is, though, as I mentioned, at 17,000 feet, you're going to get 178 knots true. We're showing right now 170, I see, and we still have another 10,000 feet to go. So the true airspeed traditionally creeps about 2 knots per 1,000 feet. So if we were to extend that, we'd be well over our 178. All of Cessna's performance figures are calculated at gross weight and most unfavorable CG. So in a speed run, it would be a full forward CG. So traditionally, when we fly normally, we tend to beat the book quite easily.
So one of the features of the new G1000 NXI is the coupled visual approaches, which we'll demonstrate here on our approach to Block Island in Rhode Island. And you load it just like you would a regular instrument approach.
Yeah, you definitely do have to be aware that it is a visual approach. It's going to take you through whatever's, if there's a ridge or antenna or whatever. So you definitely only want to do it in truly visual approaches. Down we go.
You can read a full report on the 2018 Stationair in the August 2018 issue of Aviation Consumer magazine. Reporting for Aviation Consumer, I'm Larry Anglisano, and thanks to Steve Kent at Textron for the demo.
Jet 884 to send a maintain.